everyone. So you enjoyed the last video, so I'm going to do another one. This time we're going to learn how to solve cubic and quartic equations. Cubic isn't as bad as it would seem. It's something we've already done already. So you have your equation, 4x cubed plus 3x squared plus 8x plus 6 equals 0. Sorry for the low tech, not in school. So if we look at this problem, we have four terms we think to group, right? So we're going to split our equation down the middle. So let's take the GCF of these two terms and these two terms. For the first two, it'll be x squared. We're left with 4x plus 3. And for the next two, it'll be 2. So plus 2 and 4x plus 3. So we have x squared times 4x plus 3 plus 2 times 4x plus 3. And that's all equal to 0, because we're still trying to find our solution, so we're still saying y equal to 0. Alright, so now we split it up. We get x squared plus 2 as one binomial, and 4x plus 3 is the other one, both equal to 0. Right? So now we have to do our zero factor property and solve for our roots. So for the first one, we say x squared plus 2 equals 0 and 4x plus 3 equals 0. So I'm actually going to solve the 4x plus 3 one first. The other one you might realize you have an issue with. We'll get there in a second. So subtract 3 first. Divide by 4. And x equals negative 3/4. So that is one real solution that we have to this cubic equation. Now we have this x squared plus 2 equals 0 piece. Subtract the 2 over, and we get x squared equals negative 2. Now we know we can't solve this here because we can't square root a negative, at least with what we know. We would have imaginary solutions. So what we're saying is that we have one real solution, and we'll end up having two imaginary solutions for this cubic. Alright, so let's take a look at that one on the calculator. I have my equation already put into y equals, so all we're going to do here is graph. And it's kind of hard to see if we intersect here, so let's change our window. You go to window, I'm going to make my x min and x max smaller. So we're going to say negative 5 and 5. And my y min, let's say negative 10. And my y max, we'll call it, I don't know, 30. Okay, so let's graph. As you can see there, we're only crossing the x-axis once, so it makes sense we only have one real solution. Alright, so that's the first example. That should be fairly easy because it's grouping. It's something that we've seen before. Now let's try something else. Alright, so now we're going to try this difference of perfect cubes. We have x cubed minus 64 equals 0. So we're going to use the formula a minus b times a squared plus ab plus b squared. If it were the sum of perfect cubes, that would be a plus b times a squared minus ab plus b squared. In this case, we want to set it equal to 0 because we're doing a zero factor. We're trying to find our roots. So let's first find a and b. So a comes from the cube root of x cubed, right? It's the cube root of our first term, so that's just x. B comes from the cube root of our second term, which is 64. And the cube root of 64 is 4. So a is x and b is 4. Now we can just plug that right in. So we'll say x minus 4 times x squared plus 4x plus 16 all equal to 0. Okay, everyone see where I got that? I just plugged in my x where my a is and my 4 where my b is. The middle term 4x comes from 4 times x. Okay, so from here we're going to try to solve for our roots. One of our roots is already ready to be solved for, the x minus 4, since it's linear, right? That binomial will be linear. This trinomial, though, is an x squared. So let's see if we can factor it. By looking at it, we're trying to figure out what multiplies to 16 and adds to 4. And I can tell you that does not exist. So let's try to do something else. Let's try to maybe complete the square. Or we can use the quadratic formula, whatever is more comfortable for you. I'm going to complete the square just because I know some of us had issues with that in class. So let's try that now. So we have x squared plus 4x plus 16 equal to 0. So we're going to isolate our constant by moving the 16 over. Subtract it from both sides. X squared plus 4x equals negative 16. Alright, and now we have to get our b over 2 and square it. So b over 2 squared would give us 4 over 2 squared. Right? So that's 2 squared, or 4. So we get x squared plus 4x plus 4 equals, and you're going to add that 4 to both sides, so you would get 4 and negative 12. Sorry, it's hard to get up onto the screen. Okay, so from here we can factor out that x squared plus 4x plus 4 and make it x plus 2 squared equals negative 12 square root, and we realize we have a problem. We have the square root of negative 12 somewhere on the paper. Square root of negative 12, which means that we're going to have two irrational roots again. But we can find our real root. We have x minus 4 still equal to 0 up here. And x equals 4. Okay, so let's confirm this on the graphing calculator. If we graph this, we should be able to see that x equals 4 is where our line crosses the x-axis. So plug that into y equals x cubed minus 64 and hit graph. And even with my window kind of off, you can see that one place it's going to intersect the x-axis is right at 4. Okay, so that one's done. That's pretty easy. So I mentioned we're doing both cubic and quartic. So let's try a quartic problem. I'm not going to make you use the quartic equation, which is some very complex algebra. For now, we're just going to use problems like this, where if you look at it and use your first rule of factoring, you would know to take out a GCF. There's an x in every single term, from the 4x to the 4th all the way down to the negative 15x. So let's take out an x first. Okay, so we have x times 4x cubed minus 3x squared plus 20x minus 15 equals 0. From here, we can just group. Alright, so I put this all in parentheses. I took out an x squared from the first two terms here and came out with a 4x minus 3 left over. Took a 5 out of these two terms up here and came out with a 4x minus 3 left over. That all should now be set equal to 0, and now I'm ready to make my binomials for my grouping. So I have x times x squared plus 5 and 4x minus 3 all equal to 0. Don't forget to bring down your x. We are looking for roots right now, so don't forget to use your GCF, especially because it has a variable in it, which allows us to find another root. So let's set all our factors equal to 0. So we have x equal to 0, and that's one root, okay? We don't need to do any math here. If we set x equal to 0, then that is a value for one of our roots. We have x squared plus 5 equal to 0, and if we use the square root method of factoring, we subtract 5 from both sides, try and take the square root, but of course the negative, if we try to take the square root here, we would end up with a negative under the radical, and again, two irrational roots. So then we have 4x minus 3 equal to 0 as our last opportunity for a root. Add 3 over. 4x equals 3. Divide both sides by 4. And you get x equals 3/4. So we have two real roots, 3/4 and 0, and two non-real or irrational roots. No, non-real roots, sorry. Okay, so that's pretty much it for the cubic and quartic that we'll see in class on Monday. I'm going to show you a graph of this so you can see all the roots. So let's put in 4x to the 4th. Use the caret key on your calculator to get that to the 4th power. It's right below the clear button. And then minus 3x to the 3rd plus 20x squared minus 15x. Let's go ahead and graph that. And you can see how the graph hits the origin, 0, 0, goes underneath the x-axis and comes back over it at about 3/4, which is our other real root that we found. Alright, hopefully this works and helps you. I'll see you guys on Monday. Thanks.